In the quiet depths of ponds and slow-moving streams, a unique marvel of evolution resides. Meet Argyroneta aquatica, the diving bell spider. Unlike any other spider on Earth, it spends nearly its entire life beneath the water's surface. But how does it manage this? It all begins with a masterpiece of engineering. The spider spins a dense silk dome among aquatic plants. Then it makes trips to the surface, trapping air bubbles on the fine hairs of its abdomen and legs. One by one, these bubbles are released into the web, creating a personal submarine, a diving bell that shimmers like silver. This bubble isn't just a shelter, it's a gill. Oxygen diffuses from the water into the bubble, allowing the spider to stay submerged for days. From this underwater lair, it waits, feeling the vibrations of passing prey like water fleas or larvae, and launches a swift, silent attack. Eating, resting, and even raising its young all happen within this incredible aquatic home. The diving bell spider is a testament to nature's limitless ingenuity.
Of all the strange and specialized lifestyles in the animal kingdom, few are as daring as the spider that has conquered the world beneath the waves. But as we see this arachnid resting peacefully in its underwater bell, a critical question arises. How does such a small bubble of air last so long? The answer reveals one of nature's most elegant engineering feats. This isn't just a scuba tank filled with a finite supply of air. It is a dynamic living organ. We're looking at a structure known in biology as a physical gill, a bubble that breathes. The secret to this underwater marvel lies in the spider's silk and the fundamental laws of physics. A closer look at the diving bell reveals an incredibly dense, hydrophobic web, a silken sheet woven so tightly that it holds the water at bay, maintaining a pocket of air through the power of surface tension. But its function goes far beyond simply trapping air. The bubble's large surface area becomes a crucial interface for gas exchange, all governed by a principle known as partial pressures. As the spider respires, it consumes oxygen, causing the concentration of O2 inside the bell to drop. At the same time, the surrounding pond water, though it may look still, is rich with dissolved oxygen. This difference in concentration, this pressure gradient, is the engine that drives the entire system. Imagine we could see the invisible exchange of gases happening in real time. As the spider's metabolism lowers the oxygen level within its home, the higher concentration of oxygen in the water creates a natural drive. Blue oxygen molecules are pulled from the water, diffusing across the bubble's delicate membrane and replenishing the air inside. The process works in reverse for waste gases. When the spider exhales, it releases carbon dioxide, raising its concentration within the bell to levels far higher than in the surrounding water. This imbalance forces the gray CO2 molecules to diffuse outward, passing through the bubble's surface and harmlessly dissolving into the pond. The physical gill is actively scrubbing the air clean while pulling in fresh oxygen. This constant passive diffusion transforms the diving bell from a simple air reserve into a nearly self-sustaining life support system. The spider isn't just breathing a limited pocket of air, it is actively extracting dissolved oxygen directly from the aquatic environment itself. This dramatically extends the time it can spend submerged, turning a temporary shelter into a long-term base of operations. The spider only needs to make infrequent trips to the surface. These journeys are not primarily to grab more oxygen, but to replenish the entire volume of the bubble, specifically the nitrogen, which, unlike oxygen and CO2, is not readily exchanged and slowly leaks out over time. From within its shimmering headquarters, the spider can calmly hunt, rest, and monitor its territory, a true master of its self-created habitat. This incredible adaptation is a profound testament to the power of evolution. It's a system where biology, physics, and engineering converge into a perfect life-sustaining solution. The diving bell spider hasn't just learned to survive underwater, it has engineered a way to breathe the water itself. As we watch this shimmering sphere glisten in the murky depths, we are witnessing more than just a bubble. We are seeing a masterpiece of natural design, a silent, elegant piece of biological technology that solved one of life's most fundamental challenges. In the tranquil depths of freshwater ponds and slow-moving streams, a marvel of evolution unfolds. Hidden amongst the swaying aquatic plants lies a creature that has defied the very essence of its kind. Meet the diving bell spider, or Argyroneta aquatica. the only spider in the world that spends its entire life beneath the water's surface. This is not a fleeting visit for a quick meal. This is a permanent submerged existence, made possible by an incredible feat of natural engineering. Its story is one of ingenuity and adaptation, a testament to life's ability to conquer the most unlikely of environments. To survive in this alien world, the spider must first build a home. It begins by meticulously spinning a dense dome-shaped sheet of silk, anchoring it securely between submerged stems and leaves. This silken canopy is its foundation, but the true magic is yet to come. The spider then embarks on a series of crucial journeys to the world above. Ascending to the surface, it briefly exposes its abdomen and legs, which are covered in a dense coat of fine, water-repellent hairs. When it dives back down, these hairs trap a shimmering silvery bubble of air, a precious pocket of the atmosphere it needs to breathe. With painstaking care, the spider swims back to its web, releasing the bubble beneath the silken sheet. It repeats this process over and over, each trip adding another bubble to its growing reservoir, gradually inflating the web into a luminous, air-filled dome, its very own custom-built diving bell. This completed bell is more than just an underwater shelter. It's a sophisticated respiratory organ. The shimmering structure acts as a physical gill, allowing for a remarkable exchange of gases with the surrounding water. As the spider consumes oxygen inside its home, the concentration difference causes dissolved oxygen from the water to diffuse across the surface of the bell, replenishing the air supply. Simultaneously, the carbon dioxide the spider exhales diffuses out into the water, preventing a toxic buildup. This ingenious system allows the spider to remain submerged for extended periods, sometimes for over a day, resting comfortably within its glowing pocket of air, a silent master of its aquatic domain. Life inside the bell is a hub of activity. The spider uses its underwater web as an extension of its senses, feeling for the slightest vibrations in the water. When a small aquatic insect or crustacean ventures too close, the spider darts out from its sanctuary with astonishing speed, seizing its unsuspecting prey. It then retreats with its catch, dragging it back inside the safety and privacy of the bell to be consumed. The bell is not just a home and a lung, but also a nursery. A female spider will lay her eggs and suspend them in a silken sac at the top of the bell, the safest and most oxygen-rich part of her underwater haven. Here she stands guard, protecting her future offspring from the dangers lurking in the pond. The diving bell spider is a living testament to the power of adaptation, a creature that has carved out a niche where no other spider can follow. Its shimmering silver home, glowing like a lantern in the murky depths, is a symbol of evolutionary brilliance. As it moves within its watery realm, a tiny astronaut in its own biosphere, it offers an awe-inspiring glimpse into the boundless ingenuity of the natural world. This remarkable arachnid has not just learned to survive underwater, it has mastered it, creating a life of complexity and wonder in a place it was never meant to be.